Ever wondered how to measure the length of one side of a triangle when you know the lengths of the other two? The answer lies in a principle established over 2,000 years ago by a Greek philosopher and mathematician, Pythagoras. His theorem, known as the Pythagorean theorem, solves this mystery in an elegant and simple way. Dive into the world of right-angled triangles, the stage where the Pythagorean theorem shines the brightest. In a right-angled triangle, one angle measures 90 degrees, creating a perfect corner. The side opposite this angle, the longest one, earns the title of the hypotenuse. The other two sides get called the legs of the triangle. The Pythagorean theorem states that in a right-angled triangle, the square of the length of the hypotenuse equals the sum of the squares of the lengths of the other two sides. In other words, if you square the lengths of the two legs and add them together, you'll get the square of the length of the hypotenuse. Imagine a right-angled triangle where one leg measures 3 units, the other 4 units, and you want to find the length of the hypotenuse. According to the Pythagorean theorem, you square the lengths of the two legs, which gives you 9 and 16, respectively. Add them together to get 25. The square root of 25 is 5, which is the length of the hypotenuse. But why does this theorem work? It all boils down to the area of squares. If you construct a square on each side of a right-angled triangle, the area of the square built on the hypotenuse equals the sum of the areas of the squares built on the other two sides. This geometric proof confirms the validity of the Pythagorean theorem. To summarize, the Pythagorean theorem is a fundamental principle in geometry, specifically for right-angled triangles. It states that the square of the hypotenuse equals the sum of the squares of the other two sides. This theorem provides a reliable method to calculate the length of one side of a right-angled triangle when you know the lengths of the other two. It's a testament to the beauty and simplicity of mathematics, bridging the gap between geometry and algebra, and has been a cornerstone of mathematical understanding for over 2 millennia.